by dh is equal to integral of x1 to x2 dou f by dou y alpha x into dx plus when you have to integrate. So here first limits what is there, x1 to x2 is there, no? Here x1 to x2 u into v means the limits x1 to x2 minus integral of limits x1 to x2. This term you have to write as it is. So now you have to apply that limits. How to apply that limits means upper limit minus lower limit. Alpha x is there, no? Then x is equal to x2. What to get here? Alpha x2 upper limit minus lower limit. What to get? Alpha x1. Now this term can be written as same equation. Integral first term you have to write as it is, di by dh left hand side x1 to x2 dou f by dou y into alpha x into dx plus dou f by dou y dash upper limit alpha x2 minus dou f by dou y dash up minus lower limit alpha x1, take bracket minus integral of x1 to x2 alpha x d by dx of dou f by dou y dash into dx. That meaning is second term you have to write as it is. This second term you have to write as it is. That first term upper limit alpha x2, this term same as it is, minus lower limit. So alpha x1 second term you have to write as it is. So now we'll get this equation. So now alpha x2 and alpha x1 is there. So now in statement only we know alpha x1 is equal to 0 and alpha x2 is equal to 0 when x is the extremum. That equation is extremum. Means alpha x1 is equal to 0 and alpha x2 is equal to 0. Substitute these two conditions here. So what happen? Alpha x2 is 0 and alpha x1 is equal to 0. What happen? This term that becomes 0. So what is the remaining? Left hand side di by dh is equal to integral of x1 to x2. So what is the remaining here? Right hand side. So x1 to x2 dou f by dou y alpha x into dx. This term becomes 0. Second term integral of x1 to x2 alpha x d by dx of dou f by dou y dash into dx. Now you have to see this one, this also integral, this one also integral. What is their common? So what is the common? You have to take that common. So alpha x common and dx is the common. You have to take remaining what is there. You have to see here integral of x1 to x2 dou f by dou y minus d by dx of dou f by dou y dash into alpha x. You take common, then you will get this equation. Now already you know, sir, we have di by dh is equal to 0. So di by dh is equal to 0. So what is the meaning of this one? Is an extremum, maximum or minimum. When h is equal to 0 for I to be an extremum. So di by dh is equal to 0. That meaning is you have to substitute left hand side what? That is equal to 0. So left hand side is equal to 0 means what happen here? This integral of this value is equal to 0. So the integral in the RHS of that above must be 0. Since alpha x is an arbitrary, we must have to take dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. So di by dh is equal to 0, then alpha x is an arbitrary, this one becomes 0, then right hand side that integral what is there, that one. You have to write dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. So the integrand in the RHS of the above must be 0. Since alpha x is an arbitrary, we must have dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. So this one only you have to derive dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. So this formula is known as Euler's equation. So Euler's equation. So in examination they will ask state and prove Euler's equation, or with usual notations you have to prove that dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. So in examination compulsory they will ask one question. So same question you have to practice.